Alright, so our next example on day 2 of Unit 8. For each of the following, we want you to write the words to describe the concept conveyed by the expression, and then evaluate the expression. Right? That for understanding these inverse trigonometric functions, it's important to understand what they represent. Okay, so cosine of pi over 3. Right? What is that really stating? What this is really stating is we're saying, hey, that the cosine ratio of pi over 3, right? The cosine ratio of pi over 3 is 1/2, right? That this expression is basically telling us, hey, we've got to figure out the cosine ratio of an angle. What's the angle? Pi over 3. And what is that ratio? 1/2. Okay. Then, how do we read this expression? Well, here's how we read it. This reads as, what angle has a cosine ratio of 1/2, right? We're saying, hey, the inverse cosine at 1/2. We can think of as, what angle has a cosine ratio of 1/2? Well, we know that that angle is pi over 3. Okay? But wait, what about this next piece, the cosine of 5 pi over 3? Well, this is saying the cosine ratio of angle 5 pi over 3 is, right? What is that cosine ratio of 5 pi over 3? Right? And if we can't quite remember, we can go to a unit circle, we can go in different directions, right? That 5 pi over 3 is this angle in this quadrant, and we know, oh, hey, that ratio is also 1/2. Well, wait a second, right? If the cosine ratio here is 1/2 and the cosine ratio here is 1/2, what's going to be the output for this function? Right? Well, the output is pi over 3. Right? Why is that? The reason that is because the output of the inverse cosine, right? One way I can write inverse cosine like this, another way I can write inverse cosine like that, but the output of the inverse cosine is restricted to be between 0 and pi. That's extremely important, right? So if my output's going to be between 0 and pi, then I'm saying, hey, I need an angle between 0 and pi whose cosine ratio is 1/2. Well, that angle would be pi over 3. Okay? Try that out for D, E, and F. Pause the video, think about it, try it out, unpause the video, and come check it out. What did I say? Pause the video, try it on your own. Well, this first one would read the sine ratio of angle pi over 3, right? What is the sine ratio of angle pi over 3? This one would read, what angle has a sine ratio of root 3 over 2, right? Because it's the inverse sine. So root 3 over 2 is the ratio. What was the angle? Right? And then this one, the sine ratio of angle 2 pi over 3. Well, what do we notice? The sine ratio of angle pi over 3 is root 3 over 2. The sine ratio of angle 2 pi over 3 is also root 3 over 2. Well, if both of these have the same output, but I've restricted my inverse and I've restricted my function to be 1:1, which angle do I choose for this particular ratio? All right? Well, because the restriction for my inverse sine is between negative pi over 2 and pi over 2, then my answer needs to be between negative pi over 2 and pi over 2 here. Well, what does that mean? Pi over 3, 2 pi over 3. Which of these is between negative pi over 2 and pi over 2? The answer is pi over 3. And so, what angle has a sine ratio of root 3 over 2 such that the output is in this interval? The answer would be pi over 3. Right? So the arc sine of root 3 over 2 is pi over 3. And that's if we're working in radians, of course, right? But if we're working in degrees, it would be 60 degrees. Once again, for our purposes, unless stated otherwise, we're going to be working in radians, right? And some further units, we'll come back and talk about degrees. Okay? But very, very important, the concept here. Okay? Make sure you internalize this, that the inverse cosine outputs between 0 and pi, the inverse sine outputs between negative pi over 2 and pi over 2. Why is that? That's based on how we restricted the domain. Right? Inverse sine, we restricted the domain to be 1 to 1. Here, inverse cosine, we restricted the domain to be 1 to 1. There. Very, very important. Okay? These are our limitations.